What you're about to see is an AI reading etc password off a remote server through a workflow automation platform that thousands of companies use in production. And the AI that built this exploit also built the lab, wrote the report, and validated the fix, all from a single prompt. Here's what Hacker Sidekick produced. A working proof of concept exploit for CVE-2026-21858. A critical vulnerability in n8n, the open source workflow automation platform. CVSS score of 10, arbitrary file read that chains all the way to remote code execution. The report covers root cause, reproduction steps, lab setup, and exactly how the fix works. The exploit script runs against a vulnerable target, reads any file on the server, and confirms that the patched version rejects the same request. Everything you need to validate your environment and test your detection rules. We started with opening Hacker Sidekick, creating a project folder, and typing one prompt. For this video, we are using Hacker Sidekick Enterprise, which gives us unlimited tokens, single tenancy for data privacy, and additional tools available through the MCP server. We're asking it to develop a proof of concept exploit for CVE-2026-21858, validate that the fix works, and test it in Docker containers rather than against anything in production. That's it. One prompt. Everything that follows happens autonomously. It starts by researching the vulnerability. It pulls the advisory data, technical write-ups, and patch details from the web. Then it produces an exploit development plan. The vulnerability is a content type confusion in n8n's form trigger webhook handler. When a form includes the file upload field, the handler calls a function called prepareFormReturnItem, which passes attacker-controlled file paths to copy binary file, without validating where those paths point. Send application JSON instead of multi-part form data, and you trick n8n into reading any file on the server and returning its contents in the workflow execution data. The plan lays out the approach. Build confused application JSON requests that override rec body files to point to the file path at etc password, and then verify that the patched version blocks it. It asks for the approval before proceeding. We approve it and let it run. Next, it builds two Docker containers, one running vulnerable n8n 1.120.0 and one running the patched 1.121.0 for comparison. Both are configured with the webhooks enabled and basic auth disabled so the exploit can run cleanly in the lab. It is worth noting that we did hit one Docker permissions issue that I had to fix off screen. Otherwise, everything that we did in this test is shown in the video. It writes the exploit. POC.py is a Python script that automates the entire attack chain. It waits for n8n to come up, creates a form trigger workflow with a file upload field through the REST API, sends the confused content type requests with a synthetic files object pointing at etc password, then fetches the execution data and extracts the base 64 encoded file contents. The script handles authentication, workflow creation, the exploit request, and data extraction all in one run. Iteration and debugging is the part that matters. If you've ever developed an exploit yourself, it doesn't work on the first try. The webhook isn't registered, the workflow needs to be activated through the UI, the API returns errors about production versus test mode. Hacker Sidekick does what any good researcher would do. It reads the n8n source code inside the container to understand how webhook registration actually works. It examines the database directly with SQLite 3 queries to see how the webhooks are stored. It discovers that n8n's form trigger requires a specific registration path that differs between versions. It hits a wall, debugs it, adjusts the approach, and then tries again, multiple times. This cycle of research, attempt, failure, adjustment is exactly what real exploit development looks like. The difference is that this is happening in minutes. And there it is. The exploit runs against the vulnerable container, sends the confused request, and the execution data comes back with the full contents of etc password, base 64 encoded in the workflow output. Then it runs the same exploit against the patched container. The fix is a single assertion. It checks that the content type is actually multi-part form data before processing the file fields. The patched version rejects the request with a form error. Exploit confirmed on vulnerable. Fix confirmed on patch. The report documents more than just the file read. It maps the full escalation chain. Once you can read arbitrary files, you can pull the n8n database, extract credentials, read the config to get the JWT signing secret, forge an authentication token, and use execute command node to get the full remote code execution. That's why this is a CVS 10.0. The file read is just the entry point. The report documents each step of the file chain so your team understands the full impact, not just the initial vector. What just happened? We typed one prompt describing a vulnerability that we needed to validate. Hacker Sidekick researched it, built a lab, wrote a working exploit, debugged it through multiple iterations, read source code to understand why things weren't working, validated the results against both vulnerable and patched targets, and documented everything. That's a full day of skilled security research compressed into a single session. This is what Hacker Sidekick was built for, the work that every security professional needs to do but never has enough time for, the work that every other AI tool refuses to touch. Download it at hackersidekick.com, link in the description. Reach out if you're interested in a demo for the enterprise version.